This morning, a single piece of news wiped out more market value than the entire economy of a small country. The stock crashed more than 7% in a matter of hours. And this isn't some meme stock, some speculative startup, some crypto-adjacent bubble. This is a company that for 30 straight years had zero competitors, not one. ASML is the only company on Earth capable of building the machines that print microscopic circuits onto silicon for the world's most advanced chips. If you're holding a smartphone, if you're typing on a laptop, if you got into a car with self-driving features today, there is a very good chance the chip inside it was born on a machine built by ASML. Nowhere else on the planet can machines like that be built. That is not an exaggeration. That is just a fact that has held steady for 3 decades, like something close to a law of physics. And today, July 27, 2026, investors suddenly realized that this monopoly, the one that looked permanent, just showed its first real crack. The cause wasn't inside ASML itself. No scandal, no bad earnings. The cause was Shanghai. A Chinese state-backed company just started mass-producing its own lithography machines. Not a lab prototype, not a promise on an investor call. Actual serial production, with real customers and real delivery dates, starting this year. If you think this is just another red day on the stock market, stick around. Because by the end of this video you'll understand the difference between what China could build yesterday and what it may have just learned to build today. This is happening right now, in real time, as you watch this. Hit like if you're into the tech race between China and the West. It genuinely helps the channel. And by the end of this video, you'll also understand why some analysts are already telling investors to sell ASML on this news, while others think the panic is wildly overblown. Now, let's get into what actually happened and how serious this really is. To understand why a 7% stock drop is more than just a number on a chart, you first need to understand what ASML actually does and why it can't simply be swapped out for a competitor. Lithography is the process where light projects a microscopic circuit pattern onto a silicon wafer coated in a light-sensitive material. Picture an insanely precise slide projector. Except instead of throwing an image onto a wall, it's printing billions of transistors onto an area the size of your fingernail. The shorter the wavelength of light a machine uses, the thinner the lines it can draw, and the more powerful, dense, and energy-efficient the resulting chip becomes. For most of the industry's history, the workhorse has been a technology called DUV, deep ultraviolet, at a wavelength of 193 nanometers. To put that in perspective, that's roughly 1,000 times thinner than a human hair. And that scale is still what draws the circuits for the overwhelming majority of electronics on the planet today. DUV is not the most advanced technology available, but it's what the vast majority of everything actually manufactured in the semiconductor world runs on. Chips for cars, industrial sensors, power electronics, most memory chips. Even flagship processors still rely on DUV for a big chunk of their layers. And this is where the real money story begins. When the West banned ASML from selling its most advanced EUV machines to China, Chinese factories responded by buying up DUV machines in massive volumes, stockpiling them to work around the sanctions from the other direction, using volume to compensate for being locked out of the top tier. At one point, China accounted for nearly a quarter of ASML's entire global revenue, up from around just 8% only 2 years earlier. In other words, DUV didn't just become a backup revenue stream for ASML. It became the primary cash engine coming out of China, one that was quietly offsetting the doors that had been slammed shut on the most advanced technology. And that exact revenue stream is now the one under direct threat. To put ASML's overall dominance in perspective, before we go further, this is a company whose market value has, at various points, exceeded the value of entire national stock exchanges. Built on the simple fact that if you want to manufacture a modern chip, at some point in the process, you are almost certainly renting time on a machine that only one company on the planet can build. If DUV mattered this much, why didn't China just build its own machines a decade ago? The short, honest answer: it tried, over and over, and mostly failed. Lithography is considered the single most complex manufacturing technology humanity has ever built. Arguably harder than rocket engines, harder than assembling an airliner. One ASML machine contains roughly 100,000 individual parts, positions components with precision measured in fractions of an atom, and relies on extreme precision optics that, For all practical purposes, only one company on Earth can manufacture: the German firm SEIS. ASML spent roughly 30 years and about $8 billion in R&D getting to where it is today. That's not something you copy in a single 5-year plan. For a long time, China's domestic attempts at building its own litho machines were openly mocked inside the industry. They were dismissed as crude knockoffs, good enough only for the crudest, oldest chip designs, what the industry calls trailing edge, yesterday's technology, not tomorrow's. And the weaknesses in those early Chinese prototypes were specific, measurable, not vague. First, insufficient light source power, which meant each wafer had to be exposed for far longer than on Western machines, making the whole process economically pointless at industrial scale. Second, optical systems that simply couldn't match the precision of Zeiss glass, leaving the finished circuit blurry at the finest detail level. Third, a straight-up dependency on components sourced through side channels, second-hand equipment on the resale market, or technology leaks and poached engineers. In April 2026, ASML's CEO, Christophe Fouquet, publicly stated that Chinese chipmakers would need, in his words, many years to close the gap with the company's current capabilities. Even earlier, in 2024, he put China's overall technological lag at 10 to 15 years, essentially an entire generation of engineers behind. It's against that exact backdrop of public statements that today's news landed. And here's where it gets genuinely interesting. According to a report from The Information, an unnamed, state-backed company based in Shanghai assembled an engineering team pulled from multiple Chinese firms, including a state-backed startup called Shanghai Yuliangsheng Technology, and did something that had systematically eluded the country until now. It moved from a lab prototype to actual serial production of immersion DUV machines. That word immersion isn't just technical decoration. It's the exact engineering trick that quietly revolutionized global lithography in the first place. Broken down step by step, the way you'd explain it to a curious 14-year-old taking apart a machine. Step 1. In a standard machine, there's a layer of air sitting between the final lens and the silicon wafer. Step 2. Engineers replace that air with a thin film of ultra-purified water, only a fraction of a millimeter thick. Step 3. Water bends light more sharply than air does, and that bending effectively increases the system's numerical aperture, its ability to focus light down to an extremely fine point, by close to 40%, without changing the wavelength of the light source at all. The payoff of that seemingly simple swap: thinner circuit lines, denser transistors, a more powerful finished chip, all without switching to a radically more expensive light source technology. That's the exact idea the West pioneered roughly 2 decades ago, and the Chinese team appears to have reconstructed it from scratch, with no direct access to ASML's original blueprints, through reverse engineering, poached specialists, and, presumably, months of trial and error. And this is the part where we need to talk about scale honestly, because honesty is exactly what makes this story credible, instead of hype. We're not talking about tens of thousands of machines flooding factories across China. The production target for this year is just 5 units. By 2027, that climbs to around 20. For comparison, ASML ships several hundred machines globally every single year, so in raw numbers this is a drop in the ocean. But the first deliveries are already locked in, to 3 of China's biggest chip makers: Semiconductor Manufacturing International Corporation, known as SMIC, Hua Hong Semiconductor, and memory maker Changshin Memory Technologies, or CXMT. And here's the part that separates this announcement from a decade of previous Chinese promises. 5 machines was never the point, and it was never about this quarter's profit. The point is proof. Proof that a process long considered impossible to replicate without ASML's direct involvement has now been physically reproduced, is running, and is producing output that real factories are willing to buy. And there's a bridge here worth pausing on. Immersion lithography wasn't just some minor engineering footnote when it was first introduced in the West 2 decades ago. It was, at the time, considered a genuine leap that extended the useful life of DUV technology by roughly another decade, buying the entire industry time before EUV was ready for prime time. Which means China isn't just copying a random feature. It's copying the single most important extension trick that kept DUV commercially relevant for 20 extra years, and now it owns that trick too. Markets don't react to 3-year-old rumors. Markets react to facts that change the forecast for future revenue right now, in real time. And today's reaction left no room for ambiguity. ASML shares, which had been up more than 2% before the market open on general positive sentiment, reversed and crashed within hours of the report going public, losing more than 7%, by some measures as much as 8%, dragging the stock down to its lowest level since early June. The wave rolled straight through the entire chip equipment supply chain. Applied Materials lost roughly 5%. Lam Research dropped nearly 7%. KLA Corporation fell around 5%. Technically, none of these companies compete directly with ASML. They build equipment for etching silicon, depositing thin film materials, and inspecting finished wafers, not for printing circuits with light. But investors did the math instantly. If China managed to localize the hardest, most heavily guarded step in chip manufacturing, lithography, then the next dominoes to fall are the engineering steps that are, comparatively, far easier and faster to localize. And none of this is happening in a vacuum. In parallel, the U.S. Congress is advancing a bill called the Match Act, bipartisan legislation aimed at cutting off China's access to purchasing, and critically, servicing, the exact same immersion DUV machines at the center of today's news. In other words, Washington is trying to slam a door shut at the precise moment Beijing appears to have already built itself a side exit through the backyard. And that's only part of the picture, because there's a second, arguably even more significant storyline unfolding in parallel, one that explains why the industry is taking today's news so seriously. In a high-security lab in Shenzhen, Chinese engineers, many of them former ASML employees, have spent more than a year testing a prototype machine in a far higher weight class, EUV, extreme ultraviolet, using a wavelength of just 13.5 nanometers, the exact technology that underpins production of the planet's most powerful chips, including AI processors and flagship smartphones. The team in Shenzhen is led by Lin Nan, ASML's own former head of light source development, someone who spent years working on exactly this problem for the West before returning to China. In 18 months, his team filed 8 core patents tied to EUV light source components. Independent estimates put the power output of China's current light source at somewhere around 100 to 150 watts. For scale, and to really feel how wide the gap still is here, ASML hit 250 watts back in 2017, currently runs at 600 watts as its standard benchmark, and in early 2026 announced a research system pushing 1,000 watts. That gap in raw power translates directly into a gap in manufacturing speed. The weaker the light source, the longer each individual wafer has to sit under exposure, and the less economically viable the entire process becomes at industrial scale. Zoom out even further, and this isn't an isolated event. It's one data point inside a much bigger multi-year state push. Beijing has poured enormous sums into building a domestic chip supply chain from the ground up, treating lithography independence as a matter of national strategy rather than pure business economics. Because right now, China's homegrown suppliers still cover only a small single-digit percentage of the country's total demand for advanced process control and lithography equipment. Every machine that leaves that Shanghai facility this year is less a product and more a proof of concept for the rest of the world to react to. And this is where we need to pause and say, plainly, the things that rarely make it into the headline but matter enormously for understanding the real scale of this story. Today's breakthrough is DUV. It is not EUV. And the difference between the two here isn't cosmetic, it's foundational, and it shapes everything that comes next. Without its own EUV-class machines, China physically cannot mass-produce chips at process nodes below 7 nanometers, the exact chips required for genuinely competitive AI processors and world-class flagship smartphones. The Shenzhen prototype is, essentially, a hybrid machine, partly built from components of older ASML machines acquired on the second-hand market, and partly reconstructed through reverse engineering combined with parallel experiments in solid-state lasers, a path ASML itself abandoned years ago as economically inefficient. But Chinese engineers are now pushing toward viability, reportedly reaching a conversion efficiency of around 3.42%, which is edging closer to the threshold needed for practical use. That prototype can already generate light in the EUV range, but as of today, it has not yet produced a single fully commercial-grade chip. According to estimates from the analysis firm SemiAnalysis, fully indigenized DUV tools and pre-commercial EUV machines realistically won't arrive from China before 2030. The official government target is to start producing chips on the new EUV machine by 2028, but sources familiar with the effort say a date closer to 2030 is more realistic. And even then, most forecasts suggest China will likely sit 1 to 2 full technology generations behind wherever ASML and its largest customer, Taiwan's TSMC, happen to be by that point. And TSMC is already mass-producing 2-nanometer chips today in 2026, having hit 7 nanometers all the way back in 2018. There's also the unresolved matter of ultra-precision optics, the kind only Zeiss in Germany currently manufactures, and which nobody else on the planet has fully replicated, despite Huawei's repeated attempts to poach optics engineers away with salary offers well above market rate. So today's news is a real, measurable, proven step forward, specifically in the DUV segment, the one that feeds the majority of the world's electronics and generates an enormous share of ASML's revenue. But it is not the end of ASML's monopoly at its actual core, the manufacturing of the planet's most advanced chips. Not yet. And honestly, that word "yet" is doing a lot of heavy lifting right now. And still, the entire tone of this conversation has already shifted, permanently. 2 years ago, the question inside the industry was, can China ever build competitive lithography at all? Today, the question is fundamentally different. How fast is the remaining gap going to close? And what exactly is the West going to do while it keeps shrinking, one step at a time? A technological monopoly that kept the entire global semiconductor industry in balance for 3 decades doesn't collapse in a single day. From a single news report, from a single 7% stock drop. It loses ground gradually, first in the simplest, highest volume segment of the market, exactly where it just lost ground this morning on the stock exchange. And then, step by step, it climbs upward toward the most advanced chips. The exact chips this entire technology gap was built to protect in the first place 30 years ago. The world that spent 3 decades relying on a single Dutch company as its only source for the most complex industrial machines on the planet did not announce the end of that era with an official statement from a podium. It simply started losing ground, segment by segment, percentage point by percentage point, machine by machine, exactly the way it happened this morning, live, in front of the entire world. So, how much time do you think is actually left before this gap closes, not in the easy segments, but in the hardest, most heavily guarded ones? Drop your take in the comments and tell us which scenario you think is most likely. And if this video was useful, subscribe so you don't miss what happens next in this race.